Hello everyone. Today we will be presenting our project titled Fashion Image Recognition using AI models based on the VGG16 architecture. This project was completed by myself Manisha and my teammate Dipran Bandari. Introduction. Our project focuses on building an intelligent fashion recommendation system using a CNN based on the VGG16 model. The objective is to automate the tagging and recommendation of fashion items using computer vision, which is significantly improve personalization and user engagement in fashion retail. The VGG16 model allows us to extract high-level features from fashion images and recommend similar items, creating a more tailored shopping experience. Next slide, please. For motivation. In today's fashion industry, technology is essential in improving efficiency, especially in tasks like product tagging and cataloging. Manual processes are error prone and time consuming. With deep learning, we can automate these processes, saving time and improving accuracy. This project demonstrates how we can apply pre-trained models like VGG16 to specialized tasks, showcasing the power of transfer learning in fashion image analysis. Next slide, please. Dataset overview. The dataset we have used for this project was taken from Kaggle, featuring 96 images of various fashion items like dresses and tops. Images were pre-processed by resizing them to 224 pixels and converting them to RGB to ensure consistency for our CNN model. Although the dataset was small, we leveraged the power of transfer learning with VGG16, which had been trained on a much larger dataset. Imagine it. Next slide, please. Limitations and considerations. A key limitation of our project is the small dataset, which increases the risk of overfitting. However, using VGG16, we transfer learning helped mitigate this issue by leveraging knowledge from a much larger dataset, ImageNet. Another challenge is the limited diversity of fashion items. Expanding the data set and applying data augmentation techniques in the future could improve the model's generalization and accuracy in fashion recommendations. The next slides will be presented by my friend Dipran Vandari.
Thank you, Manisha, for your time. Now I'll be explaining data preprocessing. I'm Deepan Mandari with student ID S372252, and for our data preprocessing, the preprocessing pipeline played a crucial role in standardizing the input data for VGG16. The images were resized and normalized, ensuring compatibility with the CNN. We also converted each image to the RGB format, matching VGG16's input requirements. In future iterations, we could introduce data augmentation techniques like random flips and rotations to improve the model's robustness, especially with small datasets. VGG16 was selected because of its efficiency in capturing high-level visual features. It has been pre-trained on over 14 million images, allowing us to benefit from this vast knowledge. We used a transfer learning approach, freezing the lower layers responsible for basic feature extraction and focusing on feature extraction from fashion images. This approach allowed us to focus on the essential visual characteristics of fashion items, making the system more effective for recommendation. For feature abstraction, the VGG16 architecture was designed to capture the high-level visual features from images. Through its multiple convolution layers, the model extracts intricate details such as edges, textures, colors, and patterns from fashion items. The function extract features outputs a feature vector that represents the image in a high dimensional space, which is then used for similarity calculations. These feature vectors encapsulate the essential visual characteristics needed for recommendation. Now for model testing and recommendation. We tested the model by passing fashion images through VGG16 to extract features. These features were then used to recommend similar items. The model successfully identified fashion items with similar visual features, demonstrating its practical application in a recommendation system. I will now show you the code that we ran. Uh, So this was the code that we ran, and we gave different images of tops, especially of women's, for the recommendation of fashion, and the result were provided as such. So we passed one input images, and the system recommended us more than three recommendations. Moving forward, moving forward to the visualization part and the recommendation on models, we recommended SVM, KNN, random forest, and logistic regression by comparing its accuracy and other features along with our VGG16. This was the visualization part. Here are the results of our model comparisons. As you can see, random forest outperformed the other models in precision and F1 score. Both SVM and KNN performed similarly but struggled more with class 0. Logistic regression had the lowest performance, particularly with class 1. This is the tabular form of our comparison. Now for the results and recommendation, our system successfully identified similar fashion items based on high-level features like shape, texture, and color, even when items have different colors or minor design variations. Moving forward, incorporating larger and more diverse datasets will help improve the accuracy and robustness of the model's recommendations. Now for the conclusion and future work, VGG16 proved to be highly effective in extracting fashion image features. However, further refinements are needed for even better recommendations. Our future work will involve building a customer classifier for fashion item, categorization, and increasing the data set size to ensure better feature extraction and generalization. Thank you.